Welcome back, everybody. We are starting our trigonometry unit, and today we're going to start with the very first section on the basics and the 6 trig values. So let's take a look at our right triangle. Remember that our hypotenuse is always opposite the right angle. So this is our hypotenuse. It is always going to be C in our Pythagorean theorem. And then these two other sides are the legs. And in our Pythagorean theorem, they are A and B. And it doesn't matter which one is A or which one is B. The only one that truly matters is your hypotenuse. So we've reviewed our 3 main trig functions, sine, cosine, and tangent. We now have our reciprocal trig functions that we're going to talk about, cosecant, secant, and cotangent. So sine is abbreviated SIN, and that is the side opposite over the hypotenuse. Cosine is abbreviated COS, and it is the side adjacent over the hypotenuse. And then tangent is abbreviated TAN, and it is the side opposite over the side adjacent. So there are 3 reciprocal functions. The reciprocal means we're flipping fractions, and so we are taking these side ratios and flipping them upside down. Cosecant is abbreviated CSC and is hypotenuse over opposite. Secant is abbreviated SEC and is hypotenuse over adjacent. Cotangent, COT, cot, is adjacent over opposite. Before we start working with these, just another review of Pythagorean theorem, a squared plus b squared is equal to c squared. So if we know that 8 and 15 are our 2 sides, then we are missing this third side down here, one of the legs. 15 has to be C. 8 can be either A or B, it doesn't matter. So I'm going to go ahead and make that A. So we have 8 squared plus B squared, because we're looking for that other leg, is equal to 15 squared. We have 64 and 225. Subtract the 64. B squared is 161. And then take the square root. 161 is not a perfect square. And I'm not sure that we can break 161 down. So we're going to leave that alone, not using the decimal, because right now we want to work in exact values, if at all possible. So the square root of 161 is the length of the second leg. Knowing that we just ended up with a square root as an answer, we need to go back to rationalizing radical denominators. We want exact answers, and we may end up having those radicals in the denominator of a fraction. Remember, we are not allowed to leave a radical in the denominator. So we rationalize them by multiplying. I need to get rid of the square root of 5 on the bottom, at least the square root. So I'm going to multiply the top and the bottom by the square root of 5. 3 times the square root of 5 is 3 square root 5. Remember, I'm not allowed to multiply the 3 and the 5 because they aren't like terms. On the bottom, the square root of 5 times the square root of 5 is the square root of 25, and the square root of 25 is 5. I checked this to see if I can do any reducing. Remember, the square root of 5 and 5 are not like terms, so I can't compare them together. And 3 and 5, there's nothing I can do to reduce that. So that part's finished. For the second one, I'm going to multiply by the square root of 6 over the square root of 6. Remember, on the top, we can't actually multiply them together. So we just have them sit next to each other. On the bottom, square root of 6 times the square root of 6 is the square root of 36. And the square root of 36 is 6. Reducing if we can. Remember, the 6's we can't compare. One has a radical, one does not. But the 2 and the 6 do have a common factor of 2. So I can reduce that to the square root of 6 over 3. Now that we've gotten all of this refreshed, let's try finding the 6 trig values. So the directions here are to write the 6 trig ratios for each triangle. Well, in order to be able to write my ratios, I need to make sure that I have the value of all 3 sides. And right now, I'm missing this side right here, the leg. So I'm going to make 13C because it is opposite the right angle. And 5, I'm going to make A. Again, it doesn't matter which you pick, if you pick it to be A or B. So I have 5 squared plus B squared is equal to 13 squared. That's 25 and 169. I'm going to subtract 25 from both sides. B squared is 144. Take the square root, and we get B is 12. So our missing side is 12. Our theta is over here in this bottom right corner. Now we've talked about wherever theta is, it tells us what our side opposite and what our side adjacent are. This 13 is our hypotenuse regardless, because again, it's opposite the right angle and our longest side. So because of where our theta is, our 5 is the side opposite and our 12 is the side adjacent. So I can start with sine theta is opposite over hypotenuse. 5 over 13, I can't reduce it, so we're good, we leave it alone. Cosine theta is adjacent over hypotenuse. 12 over 13, that can't be reduced. And then the tangent of theta is opposite over adjacent. Again, 5 over 12 cannot be reduced, so that's good. Now for our reciprocals, cosecant is the reciprocal or the flip of our sine. So we have 13 over 5. Secant, theta, is the reciprocal or flip of our cosine. So 13 over 12. And cotangent, theta, is the reciprocal or flip of our tangent, which is 12/5. And so these are my 6 trig ratios. Example 2. All right, we have our right angle right here. So we are missing our hypotenuse. I have to know that in order to be able to continue on with my 6 ratios. So plugging into Pythagorean theorem, we have 10 squared plus 6 squared is equal to c squared. It's 100 plus 36, which is 136. I'm going to take the square root of both sides and then see if I can simplify the square root of 136 because that is not a perfect square. So I know I can divide by 2, and that leaves me with 6 and 8. 68 is even, so I can divide by 2, and that leaves me with 34. 34 is 2 times 17. So I can pull that pair of 2's out. The 2 and the 17 down here stay underneath the radical. So our hypotenuse exact value is 2 times the square root of 34. With my theta being in the upper right-hand corner here, that makes 10 my side opposite and 6 my side adjacent. So we have sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent theta is opposite over adjacent. I have some cleaning up to do here, but I'm going to wait until after we do our reciprocal functions. So our cosecant of theta is 2 square root of 34 over 10. Our secant of theta is 2 square root of 34 over 6. And our cotangent of theta is 6/10. Now remember, these are all fractions, so we do have to make sure that they're simplified and also that we have rationalized our denominator. So I'm going to start over here with our sine theta. 10 and 2 I can reduce to 5 and 1. I also have to make sure I rationalize that denominator. So I'm going to multiply both the top and the bottom by the square root of 34. So my sine theta is 5 square root 34 over 34. For my cosecant, I can reduce the 2 and the 10. The 34 is on the top of the fraction in the numerator, so I don't have to do any rationalizing for that. So that's the square root of 34 over 5. For my cosine, 6 and 2 can reduce. I also have to rationalize this denominator by multiplying by the square root of 34. So my cosine is 3 square root of 34 over 34. For the secant, the 2 and the 6 reduce. Square root of 34 is on the top, so I don't have to worry about rationalizing that. So that's the square root of 34 over 3. And then my tangent, 10/6 reduces to 5/3, and the 6/10 will then be 3/5. So these 4 and these 2 are my 6 trig ratios. All right, example 3. We have side lengths of 5 and 10, and we need our hypotenuse, which is c. So we have 5 squared plus 10 squared is equal to c squared. That's 25 and 100, which is 125. Take the square root. 125 is not a perfect square. So we're going to break down 125. I have a pair of 5s with a 5 left over, which means our hypotenuse is 5 square root of 5. So starting with my sine, theta, well, let's label our sides here. My theta is up here, so this is the opposite side and the adjacent side. So sine theta, we have 10 over 5 square root of 5. Cosine theta, we have 5 over 5 square root 5. And tangent theta, we have 10 over 5. Cosecant theta, we have 5 square root of 5 over 10. Secant theta is 5 square root of 5 over 5. And cotangent theta is 5/10. So now if I reduce, the 5 and the 10 reduce to the 2, and then I have to rationalize that denominator by multiplying by the square root of 5. So our sine is 2 square root 5 over 5. Our cosecant theta, again, I can reduce the 5 and the 10, but because the radical 5 is on top, I don't have to rationalize, and that's the square root of 5 over 2. For cosine, I'm reducing the 5s, leaving a 1 on the top, and then rationalizing the denominator by multiplying by the square root of 5. So cosine is the square root of 5 over 5. And then my secant, reduce these 5s, and I get the square root of 5 over 1, or you can just write the square root of 5. My tangent, 10/5, reduces to 2, and my cotangent, 5/10, reduces to 1/2. All right, example 4. You're going to try on your own and bring it into class so we can check that for credit. Now we're going to go into what if they don't give us a triangle with side lengths? What if they give us a trig value instead? So go ahead and draw a right triangle. Doesn't matter if it looks like this or like this, wherever you want your triangle to be. After you've drawn your right triangle, then pick a corner to put your theta in. Doesn't matter which of the two corners that are left that you put your theta in. I'm going to label based on my theta. You know, hypotenuse is always the longest side. This would be the opposite, and this would be the adjacent. They're giving us cosecant. Cosecant is hypotenuse over opposite. So we know that our hypotenuse is 8 and our opposite side is 3. They want us to find the tangent, which is opposite over adjacent. Well, I know the opposite, that's 3, but I don't know the adjacent. That's okay because they've given us enough information to use Pythagorean theorem. So I can say 3 squared plus b squared is equal to 8 squared. That's 9. and 64. Subtract the 9. B squared is 55. And take the square root. We get B is the square root of 55. I can break that down into 5 times 11, but that doesn't actually reduce anything for me. So this is the square root of 55. So our side adjacent is the square root of 55. Now again, we can't leave it alone like this. We have to rationalize it. So we're multiplying the top and the bottom by the square root of 55, which gives us our tangent of theta being 3 square root of 55 over 55. Let's try example 6. They're giving us cosine. So I'm going to start with drawing my triangle. Got my right angle and my theta. Cosine is adjacent hypotenuse. So we have H, O, and A. I know H is 5 and A is 2. They want cotangent. Cotangent is adjacent over opposite. So we know the adjacent is 2, but we don't know the opposite. So we're again going to go ahead and check out Pythagorean theorem. We have 2 squared plus b squared is 5 squared. 2 squared is 4. 5 squared is 25. Subtract 4 from both sides, and we get 21. Take the square root of 21, which we can't do because it's not a perfect square, and we get the square root of 21. 21 breaks down into 7 times 3, but there's no pairs in there for me, so I can't simplify that. So our side opposite is the square root of 21. Rationalize your denominator, multiplying by the square root of 21 over the square root of 21, and we get our cotangent of theta is 2 square root 21 over 21. Okay, example 7 and 8. You guys try it, and ladies, and bring it into class tomorrow for us to check. And that's it for section 1. Have a great day.